Alright, so today's video I am going to assemble and install this nifty little thing in this box. Alright, so as many of you may know, the Marshall JCM 2000, DSL100, and TSL100s have been known to have a runaway bias issue. Of course, you can replace the PCB and hope that it's going to cure the problem, but 9 times out of 10, because of the way that they're laid out, it's going to overheat and mess up eventually again anyways. I've got a JCM 2000. It's an older one. I'm not sure exactly which model it is, but it does have the stock PCB in it. I have not had any issues with runaway bias. However, I have recently been having issues with it cutting out of practice. Mid-song, volume drops, cuts out, does weird stuff. So I need to get in there and check it out. I just actually tested the bias and it's stable. Both sides are fine and in the same place that it was when I tested it and set it. Tube amplifiers and guitar amplifiers in general carry a large amount of current. They also store a very large amount of electricity that could seriously fuck you up. So if you don't know what you're doing, stay the fuck out of your amp. Alright, now I remembered to press record again this time, so I'm just going to repeat it. The first thing is you get this nifty little sticker. Okay, it's not little, it's fucking enormous, but there you go. That's the place you go to get this thing. And the kit, I think it was 40 bucks, which ain't bad. I also got the hollow drill bit. What this is for is because you need to cut out the pin on your output valves, which is, I think it's pin 5. I don't know. I got to read the instructions. But I got that just in case. And then it comes with this package of crap. So they also offer this assembled. It's just a few dollars more. But, you know, I like to tinker with stuff and put things together. And I'm a cheap bastard. So that and the instructions, which I'm going to have to read, of course, and once I take this thing apart, pull up a schematic for my main board, and oh, nifty, look, he labeled everything in the pictures. That's a great idea. I was just going to write it down on a piece of paper, but whatever. Yeah, so there's the unboxing, and now I'm going to get to this thing together. Alright, so first things first. Hope I got a good angle here. You guys can see what I'm doing. I'm going to remove my resistors. Which, by the way, are not labeled. That's okay. And these guys. If you can't see, because it's off screen, what I'm doing is I'm setting my parts off here to the side, to my left, so that I have them nice and organized. I'm not going to need these wires, because those are just now, because they're jumpers. This is a jumper. This is capacitor, the PCB, and the last 2 components. So I am going to set everything upright where I can see. Set you over here. All right. Yeah, as you can see, it's all labeled where everything needs to go. So I'm going to pause this real quick. I'm going to double check the ratings on my resistors here, because they are not marked, and I need to read the band so I know which ones go where. So I'll be right back. Alright, so I got that sorted. Now, the way I like to do my PCBs is start with the lowest height component first. So start with the resistors, because they are the lowest height. What I do is I mark the ones that go in. This is the
case 6, which goes into our 3, 4, 5, and 6. So we look on here, there's a 3. That's why I do this. Let's go ahead and make those stilts. I'll take that one out and flip it. I'm stupid. So put them through. I give them a little bend out so they stay nice and tight on there. These other ones going. And 5.6. 220s. Here we go. And then R1 and R2.
All right. Now the difference, apparently, in these two assemblies, the main difference is going to be the 0 ohm link, which is this guy right here. The DSL50 and 100 both use the 0 ohm link, while the TSL models use the 680K, which is the blue one. See, this one's got a little single black band. That's your 0 ohm link. Now, for these PCBs, I like to work at 350 degrees Celsius with a small tip and fine solder.
Alright, now I do have a smaller set of snips around somewhere, but I don't know where they're at the moment. So let's come in and trim all this stuff off of here. Keep all this crap out of the way. Now, I got a couple of capacitors that need to go on here. And since, well, actually, I'll do these guys because they are the next highest ones. We got cons. I'll do that one. And that one. And that one. And this one's a little lower than the other two, so what I'm going to do is I'll pop these out and do it first. Dude, what the fuck? Looks like I need to replace my tip. pita sandwiches. Let's just see one. Alright, I'll take a little break to see if I had some better quality capacitors here, but I don't have anything of this rating at 63 volts, so I'm just going to stick with what came in the kit here. C2. These two guys, the 22s. Probably mean us, but I know. Yeah, 3 different holes. I guess that's what you use 3 different capacitors. I don't know which way is what. And it's not marked. Put the lettering toward me since everything else is facing this direction. And then it's not marked, so. What's the worst that could happen? Oh shit, I got leftover parts. Alright, now, all that's left are running these leads here, and I'm not quite sure how that's supposed to go. I got these standoffs that come in the kit. Let's go there, but it shows on here there's a spot for these jumper tabs, which aren't installed. I'm assuming that V8 to V4, V4, V5, 6, 7, 8. Oh, look, it even says on here, connection JST 67BH. I guess that's 1, 2, and 2. The wire goes on to con 3. And red wire, con 5 side. Okay. Alright, so I gotta trim this wire down. And it says I'm going to need 2 3 1/8-inch pieces. Which, I'm going to have a little handy dandy ruler out here. And of course, I'm losing 30 seconds, so 30 seconds is 1/8. There's 3 1/8, so then I need 2 4 3/4. So there's got to be something better on those. 7/5. Yeah, I should have 2 8-inch ones. Just kidding. Alright, so. Oh. Two, 1, 2, 2, 8's going on 3, red on 5, and yeah, you're fucking kidding me. The way I do that is I stick it in there and I fold the wires over so they don't fall out the bottom. 3, and I'll show these. There we go, hook on 4. It's a red shorty and a long yellowy. Nope. 4 gets a long one and a short one. A little bit more off there because I lost some wire. Alright, what I just did there was backed up so I make sure that my wires is nice and flush with the piece of D. trim. Sorry about the interruption. That was a honeydew request. But I will take care of some of them doing this. Son of a bitch. Jeez Louise. Typically I'd use these fancy little alligator clips. But I'm using the old iPad to record this, so struggle I shall. Toothbrush gun.
Alright, and there it is. Dun dun dun. Hopefully, these junctions, jacks, things here will function properly, even though I had a little bit of issue with them. It's the first time I've had to replace or install these, so perhaps I shouldn't have turned up my iron beforehand. Alright. Shut it down. Gonna do the honeydews. I'll be right back. Alright, so I'm back from taking care of that honeydew real quick. Alright, I got the PCB assembled, so I'm gonna put it back in the box over here, clean up my mess, and get to taking my chassis out of the head case. Pardon my mess. So you may have noticed that the red and yellow wires in the middle there were backwards from the two outer red and yellow wires. I fixed it off a camera, so when I did the installation it was correct. As long as you know which one's which, it doesn't really matter which side it's on, I don't think. So just make sure you're paying attention. Don't let the honeydews fuck you up like they did to me. Alright, I have found that the easiest way to remove this chassis is to lay it face down. You take out these 4 screws. These 4 screws. And lift it out the back. Alright, so you're going to want to jack it up some kind of blocks. I don't have a fancy amp stand. So that way you can service it to get in here with the valves in it, because you're going to need the valves in it. Alright, so this is the inside JCM 2000. And I'm going to have to take this whole back off of here, and so I can get in there. So, with that said, I need to figure out how I'm going to set up this camera so you guys can watch. Alright, so I did some fiddling around and got the buzz to kind of subside a little bit. Apparently I've got some dirty connections in here. So I'm going to take a little trip out to the garage, get my cleaning stuff and some dielectric grease. I'm going to get all these pins cleaned up, some fresh grease on them, and then I'm going to start pulling off the output board so I can get down here to the main board. So this stuff right here, both made by CRC. You can get them at Home Depot. Got your dielectric grease there on the left, which is silicone grease. And what that does is it protects all of your raw electrical connections from getting oxidized in the first place. On the right is a precision lubricant made for electronics. See that right there? Electrical properties. Now, there is some debate. Could be some debate. I don't know. Most guys just use the deoxit and clean all the crap off, and then they're continually using deoxit over and over and over and over. While these two products right here will keep you from having to use that deoxit over and over and over. The spray on the right actually does the same thing as the deoxit because it cleans as it lubricates. The thing on the left, well, it may attract dust, but it keeps oxidization from happening. I used it on tube pins. I use it in my jacks. I use it on all those little connection pins and tabs and all of that crap in there. Now, I have not done this amp yet, at least not the inside, so I think that's probably what's causing most of this noise, because I'm looking in there, and if you can see, where are we at? On these switches, how dark and oxidized that crap is, right? Well, they're dry, and they're oxidized, and that in itself creates resistance in your electrical current. So keeping them wet will keep a better connection. Those are the power caps or the capacitors in this amplifier that will knock you on your ass or possibly kill you if you fuck around with them. So by all means, do not ever touch those leads until you can safely discharge them. There's a way to do that, which I'm not going to go into in this video, and I'm not going to bother with it either because, fuck it, I'm suicidal. Oh shit, I almost forgot I was making a video on this. So I went through, I found out what was making the hum. I had a broken tab right here, so I resoldered the back of it, wherever it is, right there, right there. Reflowed that, and then reflowed a couple of these other solder joints on here that were kind of funky on these resistors on the output board there. Alright, so I've gone through and I have removed everything from the main board. I marked everything, and of course I took some photographs of where all this stuff over here goes. This one obviously goes to the output board here, and then all the rest of these I have numbered with their corresponding connection number on the main board. So they're all flipped over. Of course, both the green wires over here go to the end down here, and then my output cable harness to my output transformer is hanging off the side. I've already got the screws out, and I'm about to lift this thing out of the chassis now, so I'm going to take a quick little break, and I'll be back with some more video once I get the PCB on. Alright, so now I have the entire main board out, and this is what it looks like. And this, alright, now instruction says Best to remove as much solder as you can off pin 5. It makes the drilling process a whole lot more efficient. Alright, well, I had intended to use my Dremel tool to do this, but I don't have the right chuck for it. So, here we go. You want to make sure you're using the high speed Give you a close up. Make sure I'm getting this. So you gotta clear the whole hole. Now, here on V5, you can see up here, where am I at? Right there. Knock the pin off, but there's enough in there that I can grab onto, so I'm not overly concerned with it. So I'm going to tin the ends of all these little guys here, make my connections a lot quicker.
This is a 22 gauge straight of wire, so I've been struggling trying to strip it with my 20 gauge wire stripper.
The whole point of doing this is it's going to make my mechanical connections easier to do. Alright, so I already did my pin 5 on V6. So the two yellow wires respectively go to V7 and V8. I did V6 so I can go ahead and set this guy up in here. Kind of bothers me that it covers the fuse, but it's not that big of a deal, I reckon. So I'm going to go ahead and just stick this sucker in here because I got the hard one out of the way. The whole reason you remove those two capacitors there is so that you get a place for this foot to sit. Standoff. Now what I did was I put my standoff right here on the edge. And you gotta make sure you got room over here for your W3 connection. Move that out of the way there. And for a mechanical Well, I forgot to start the camera before I put it all back together, but it's all back together. So you can see, put it all back together. You can see down there where it's at. It's sitting right up on top of there, and those nice little risers where I ran the wiring. Also fixed this tab while I had it out. Where's that? Right here. A little solder joint was broken on the back of it. I went through while I had all these connections off, and I greased every last one of them with the dielectric grease. This amp is super quiet now, makes no noise compared to earlier. Millivolts. Upon powering it back up and testing it, it was 88.5 millivolts. So that tells me that the conductivity is much better with this new system. I played it for a little while, and man, it sounds like my amp. It just doesn't make all the racket that it used to. Thanks for tuning in, and hopefully I get all this edited and get some people to watch this. Thanks. Bye. Make sure you hit that like button.